Unmute. Anindita, unmute yourself. Anindita, unmute yourself.
Yes. Yes, ma'am. Am I audible? Yes.
Yes.
Yeah, very much.
Yes. Artificial intelligence becomes intelligent only when it learns. And today, we explore how learning happens. Respected patron mentor, Dr. Abha Khandelwal, ma'am. Respected President of AACST, Dr. S.B. Kishore. Respected Principal, Dr. Amina Wali. Distinguished resource persons, organizing committee members, Ganesh Kedar sir and Mahesh sir, and their participants. A very good evening to everyone. I warmly welcome you all to day 2 of our national workshop on artificial intelligence, concept-centric and industry-oriented. Yesterday in session 1, we built a strong conceptual foundation by understanding what artificial intelligence truly is. That is, its types, categories, components, responsible mindset required while working with AI. Today, we move one step deeper. If session 1 helped us understand what AI is, today's session will help us understand how AI learns. Our topic for today is machine learning and deep learning, core learning concepts. In this session, we explore what machine learning is and why it is required, the different types of learning, that is supervised learning, unsupervised learning, and reinforcement learning, core terms such as dataset, features, labels, training, testing, and model generalization, and conceptually understand deep learning and neural networks. This session is crucial because machine learning is the engine that powers modern AI system. It transforms data into intelligence and patterns into predictions. I am confident that today's session will enhance your conceptual clarity and prepare you for the advanced topics in the upcoming session. It's now my privilege to invite our respected patron and mentor, Dr. Abha Khandelwal, ma'am, founder of AACST, to kindly deliver the welcome address for session 2.
Namaste. Good evening, everyone, and welcome to session 2. After an enriching exploration of foundational concepts and a thoughtful understanding of industry requirements in yesterday's session, today we move a step ahead from knowing ideas to understand them in depth so that you can translate them into meaningful implementation in future sessions. True learning begins when concepts starts connecting with practice, and for that, this middle path is must, going in deeper and understanding them with more clarity. All participants are expected to actively engage, reflect, and make most of this opportunity. And of course, since this is an online session, you are expected to keep your mic muted, videos off, but let your minds remain in super active mode. Silence on screen, but full volume in thinking and understanding. Right, dear participants? So today we are privileged to learn from very talented Dr. Mahesh sir, and I am confident that his insights will further energize all of us to learn, adapt, and innovate. And now it gives me great pleasure to introduce our chairperson, a scholar whose academic journey reflects dedication and distinction, Dr. Ganesh D. Kedar sir. Professor and Head, Department of Mathematics, RTM, Nagpur University, an esteemed academician and a valued university colleague of mine. A mathematician shaped by rigorous scholarship, Dr. Kedar earned his PhD in mathematics from RTM Nagpur University and completed his MPhil from Periyar University, Salem, with specialization in solid mechanics and operations research. Disciplines that harmoniously integrate theoretical insights with practical applications. With over 3 decades of devoted service to higher education, he has progressed from lecturer to professor, inspiring generations of students and mentoring numerous research scholars. Several candidates have successfully completed their PhD under his guidance, and he continues to lead research in advanced mathematical and applied domain with clarity and vision. Dr. Kedar has undertaken UGC and university-funded research projects contributing meaningfully to the advancement of mathematical sciences. Conference proceedings, authored books, and presented on national and international forums as a session chair and academic leader. He brings depth, precision, and thoughtful engagement to scholarly discussions. He also contributes actively to academic governance through his involvement in Board of Studies and academic councils. As a life member of Indian Society of Theoretical and Applied Mechanics and Indian Science Congress Association, he remains closely connected to the broader scientific community. Under his leadership, 6 days national level online short-term training program on artificial intelligence in mathematics, innovative field, was organized by YCCE in collaboration with RTM Nagpur University. On the occasion, he highlighted the transformative role of artificial intelligence in advancing mathematical research and pedagogy. On a personal note, it gave me a great pleasure to welcome a respected colleague with whom I have shared enriching academic association over the years. Today, we are honored to have with us not only an accomplished mathematician, but also a mentor and leader. It is with sincere respect and admiration we welcome Dr. Ganesh Kedar as the chairperson for the session. With this, I would like to hand over or call Mitali to introduce our resource person of the session. Mitali, over to you.
Mithali, unmute yourself.
Yes, ma'am. Sure, ma'am. Thank you, ma'am. Dr. Mahesh Kumar is serving as Assistant Professor in the Department of Computer Science at Bhavans Vivekanand College of Science, Humanities and Commerce, Sainikpuri, Secunderabad. With over 21 years of teaching experience, he has made significant contributions to academics, research, and curriculum development. He completed his MSc in Information System and MTech in Computer Science and Engineering from Osmania University, Hyderabad, and obtained his PhD in Computer Science and Engineering from Jawaharlal Nehru Technological University, Hyderabad. He has also qualified for UGC NET in computer application. His areas of expertise include cloud computing, big data analytics, artificial intelligence, machine learning, blockchain technology, Internet of Things, information security, and Python programming. Dr. Mahesh Kumar has published research papers in reputed national and international journals, including Scopus Index publication, and has presented papers at IEEE and other prestigious conferences. He is also a co-author of the book Machine Learning, first edition, December 2024, and holds a published patent titled Dynamic Management of Relay Nodes in Wireless Network. An active academic administrator, He has served as BCA program coordinator and NAC criteria in charge, contributing to institutional quality enhancement initiatives. He has delivered invited lectures and conducted hands-on sessions on generative AI, data visualization, information security, and blockchain technology at various academic platforms. Dr. Mahesh Kumar is an active life member of the Association of All Computer Science Teachers, reflecting his commitment to professional collaboration and the advancement of computer science education. He is also the recipient of the Faculty of the Year at LEAP 2025 award by the London School of Digital Business, UK. Thank you so much. Over to our research person, Mr. Mahesh Kumar. Thank you.
Sir, it's a request to declare the session open. So over to Dr. Ganesh Kedar, sir, please declare the session open.
Yes. So, ma'am, at the outset, I am very much thankful to you to invite me as a chair to this session for the eminent personality who is going to deliver this lecture. So, I welcome Dr. Mahesh Kumar, sir, and I declare that this session is open. And after the session, we will have the question answer and we'll take the questions from the audience. Thank you. So over to you, Dr. Mahesh Kumar.
Thank you so much, sir. So respected Dr. Abha Khandelwal, founder, Association of All Computer Science Teachers, then Dr. S.B. Kishore, president of AACST, Dr. Amina Wali, principal, Sadabai Raisumi Women's College, Nagpur, and Dr. Ganesh sir, chairperson of today's workshop, then Ms. Ananta Kundu, convener of this national workshop, distinguished professors, faculty, and my dear students. Good evening, everyone. And special thanks to Mitali for introducing me for this session. So before I start, I will share my screen. Is the screen visible?
Yes, sir.
So I'll start my presentation. So the topic for today is machine learning and deep learning with the core concepts. And the agenda for today is the introduction to machine learning, why machine learning is required, then types of machine learning under which we cover supervised, unsupervised, reinforcement learning. After that, we are going to cover the basic terms in machine learning, what we use, such as dataset, features, labels, training, testing, model, generalization. Then at last, we'll cover the concepts of deep learning. So coming to the introduction part, actually, what is machine learning? So here I put a statement like a branch of artificial intelligence that enables computers to learn from data and improve their performance without being explicitly programmed. So earlier to machine learning, we were trying to write some coding. Now nowadays AI has been very much flexible for us, where we are trying to skip that coding part, which most of them are not liking to code and spending a lot of time in that. Now there, the machine learning has been playing the main role, where we are trying to feed some data to the model through some algorithms, and the system or the machine is being learning itself based on the algorithms what you're trying to give. So here we can see a term called explicitly without it being explicitly programmed. So we are not programming. We are trying to make the computer to feed with some data. And we have a lot of algorithms through which we are trying to make some predictions for the future predictions. Because when you go for these industries, right? So there we want to just see what sort of future scope we have for a particular product. Then no one is going to sit and just study with a lot of papers and trying to summarize for 100 papers and all these things. No. So they use the models, the machine learning models, and based on that, they give the requirement, and within seconds, they are trying to generate some output. Okay, so those are called as the predictions. So based on the predictions, we try to make a decision like we need to move for the particular product or not. So here it finds patterns in data and make decisions or predictions without human intervention. So as I was saying, that humans are not been involved so much right now, because you are trying to put some algorithms, you are trying to give some data, then based on that you try to give your input, and based on your input you are getting your answer, the final answer, within fraction of seconds. And that particular prediction, based on the prediction, you need to decide whether to move forward or not. So here the machines are learning from experience. So learns from experience. So whatever the data you're feeding, what sort of predictions it has already made. So based on that, any sort of new problem has been arised, you feed into that particular system, then you're going to get a prediction. Then it finds the patterns. Okay, if suppose I want to just check whether a particular mail is spam or not. Now in Google, you can see separate tabs for just go for some updates, some promotions, for some mail spam, or so different tabs are there. Now, how you're getting the particular mails as a spam? So how you are going to identify? Now there we try to use some keywords, some sort of rules. Based on that, it is going to identify whether it is a spam or not. Then we go for building the model based on the algorithms. And finally, by using all these things, we are going to predict the outcome. So human intervention is less. The machine is going to do a more, and that too within fraction of seconds. So ultimately, obviously, we want to go for this machine learning. Then, now here we have rule-based systems fail under variability. Now, what do you mean by this? So rule-based systems operate using fixed human-defined if-then rules. Now, most of you might be the coding people from computer science background. Maybe you know, maybe the other teams also have an idea about the programming. So there we use generally the if-then rules. Okay, you might have studied some conditional statement sort of programming. So there we generally use. Now these, whenever you are using these sort of statements, you are explicitly writing the particular code, then that comes under the rule-based systems. While they work well in stable and predictable environments, they struggle when real-world conditions become variable or uncertain. Now, when you write the certain code with using these particular rules, now that is static. Maybe it is going to only work only for a predefined problem. But now the world is not like that, right? Day in and day out, we are trying to just check some real-world problems. Now, how does your machine is going to predict or give the solution instantly for the real world problems? Now, that is the ultimate thing what we need to focus. If you go for if-then rules, which is traditional, we need to give only the predefined problems and you get a predefined solution. But what about the real world problems? So there we need to go for the machine learning, right? Now the reasons for rule-based systems fail under variability is one, explosion of rules. Now here real world problems often have too many possible situations. So a number of real problems comes in day in and day out. So to handle every variation, rule-based systems require an enormous number of rules making them. So how many rules you are going to write? Like you go on writing some 1,000 lines of code. So if you go on writing like that, it is difficult to design because lines are lengthy and it is only static for few problems. What about real world problems? Then it's hard to maintain. The complexity is increasing because you go on writing some number of lines of code. If you want to find out some sort of thing, you need to go for which line. So it's very hard to maintain. Then it is very much error prone. If any error occurs, then obviously the tracking of that particular error has been problem. So small changes in input can require new rules leading to rule explosion. So if any sort of changes you want to make, then obviously the whole code might be a little bit disturbing and you need to change for that one. Now coming to the second reason, inability to handle unseen cases. Now rule-based systems can only act on predefined conditions. So which is static, what I was mentioning, right? So when they encounter new patterns, suppose suddenly a new problem has arrived, then unexpected inputs have been given. Then the inputs, whatever is been given, it is been not complete. So there is some missing of data, which is called as noisy or incomplete data. Then what? So then the rules, whatever you have framed, is not going to work. So they fail or behave incorrectly because no matching rule is existing. Because your problem is new, but the rules are old, then obviously that is not going to match. So that is one reason where your rule-based systems, which is a traditional system before machine learning, is going to fail. Now coming to the third reason, lack of learning and adaptation. Rule-based systems do not learn from experience because they are static. Already rules are framed. So many number of lines are created. It has been only working for that. So what about so how you are going to make your system to learn? But in machine learning, we can make through experience. So now the problem is they cannot improve over time. They cannot adapt to changing requirements. They cannot generalize from past data. Any update requires manual modification by experts is required. Again, the same older traditional story, you need to go and spend for a number of hours to change. It might take some few days also. So that is not going to work these days. Okay. Now coming to the next reason, poor scalability. As variability increases, rules become complex and interdependent. So your problem is complex. The rules are also been increasing. That means the lines of code is also been increasing, which is going to create some complexity. Then conflicts between the rules arises. So one rule might link with the other rule. And everywhere you need to keenly observe to modify. Then also, as the number of rules are increasing, obviously the system performance also gets degrades. Okay. So this makes scaling rule-based systems impractical for dynamic domains. So as the number of lines are increasing, complexity is increasing, then system performance is down, then obviously no one wants to go for that particular situation, right? The scalability means what? Increasing, right? So poor scalability. So you're going for increasing, but the problem is the conflicts are increasing, the system performance is low. Okay. Then sensitivity to noise and ambiguity is one more reason. Real world data often contains what? It might contain errors. That means the data is not correct. Then uncertainty, the data is not relevant, the data is missing, ambiguous inputs, so there is no proper input, whatever. So these are the things what you are going to get in real world instantly, real world problems instantly. If you have the problem, that means 2 different problems, no, then obviously we frame very nicely, okay, this is the problem, this is the solution, everything is over. But the real world problems, we cannot expect what sort of problems arises. Then what sort of solutions we need to take out from that. And we don't have that much time to predict. That's where your machine learning comes into existence. So rule-based system expect exact matches. So even slight deviations can cause failure. So whatever the inputs you are giving, it need to match you with the rule, whatever you are offering. If there is a mismatch, that particular rule-based system is out. So these are few reasons why the traditional rule-based systems are being failed. Then we go for the machine learning. So why machine learning? So machine learning is required to make sense of massive amounts of data and solve problems that are too complex for traditional programming. So traditional programming means the programming before your machine learning are called as traditional programming. Now the problem here is it is not going to handle a very huge amount of data. It is not going to predict from that particular data because the data is somewhat missing, some sort of uncertainty, some sort of error prone data has been there. Then in such cases, the machine learning is going to take care in order to remove the missing, that means the missing values can be cleared, the errors can be minimized, then it can adapt to any type of data. And here we talk about massive amounts processing. So processing large amount of data. And obviously we see what is big data. Now up to certain range, we call it as a data. Now, when you talk about 1 terabyte and above, we replace it with big data. Now, in order to go with the big data, then obviously we require very huge number of resources for processing. It could be computing, it could be storing. Okay, now when you talk about machine learning, obviously your data comes under the category of big data. Because whenever your data is big, your predictions are good, your decision making is good. Now, that is the reason we talk about big data. Now, no one is going to talk about data, only big data. Terabytes of data, gigabytes. more than that, petabytes of data, yottabytes of data. Now, these all comes under the big data. So here your machine learning is going to analyze big data to find what patterns and insights that would be impossible or time consuming for humans to process manually. You cannot sit and do manual work with lots out of thousands or lakhs or crores of records. That is impossible. Okay, now that's where your machine learning comes into existence, which is going to process massive amounts of data. Then automatic learning and improvement. So learns from data and improves automatically as it gets more data, leading to better predictions and decisions over time. So your work is to give data. Your work is to provide a selective algorithm. Then obviously, based on that, you get a proper prediction or proper decision, which is going to benefit for your industry. Ultimately, the industry wants profit, right? But they don't have time to sit and do manual work. So they go for the machine learning, feed the particular data. So based on the algorithms, whatever has been set up, you get that, right? So that's where it is going to learn itself. Then complex problem solving. It solves problems that are too complex, dynamic problems, or supply for traditional algorithms or human capabilities. The complex problems are not solved with the traditional programming. As I was saying, that there is a problem with the rule-based system. A very huge complex problem we cannot sit and write for rules, number of lines of code, right? The same thing can be solved with the help of the machine learning, where you give the data, you give the patterns, you try to put some algorithm, then obviously your work is be done, and within fraction of seconds, you are going to get your predictions. Now, once you get the prediction, you need to think yourself whether it is correct or not, because you need to justify yourself whether to go forward or not, right? Simplifies and automates tasks that are difficult, time consuming, or impossible for humans. Now, for these reasons, we go for machine learning. Now, these are few applications what I put for the machine learning. Like we have stock market trading. Now, these are all industry based. The stock market trading. Now, whenever you go for the shares, whenever you go for the market business, then obviously the machine learning is trying to predict whether to go for that particular stock or not, whether you go for that sort of business or not. So yes or no concept is also been embedded into your machine learning. We call it as categorical applications. Then you go for online fraud detection. Now the cyber attacks, cyber fraud is going on. So what sort of attacks, in what way we need to identify whether the particular fraud has occurred or not. We need to detect, right? Once we detect, we need to solve the problem. So how? So through machine learning, you can do that. Then we have virtual personal assistant. Now we have some Alexa, Siri, and all virtual personal assistants. Then that there also the algorithm and data has been fed. Now, whenever you just talk to the particular device, then obviously it is going to respond for you. Then how the particular thing has been going on. There also these sort of algorithms have been embedded. Then, as I was saying, email spam and malware filtering. Now, when you go for these intrusion detection systems, I was talking about the network security concept, intrusion detection systems, or some malwares have been there. Now, there need to be some sort of algorithms where it need to find out that, okay, this particular email is going to the spam category or not. Based on some keywords, based on some sort of terms, you are going to fix that, okay, if you find this term in your email, no, then that comes to your spam mail. Otherwise, no. Similarly, whenever some packets are coming to your network, then obviously that packets need to be monitored, and we need to identify that it is containing some malware. Malware means some sort of virus, sort of defective thing, which we need to identify. We cannot let that particular malware to enter into our network. So there also the machine learning comes into existence. Then we have some self-driving cars, autonomous cars. Now there also we do have some lot of sensors embedded into the self-driving cars. So obviously there is no driver. Then how come that particular system identify the street, the lanes, the lights, the traffic lights? Now that's where your machine learning comes into existence. Then product recommendations. I hope most of you are going with Amazon. Okay, then obviously maybe sometime you try to purchase a product, you search or browse the product information, but later on you couldn't buy. And some other time you just log into that, and the Amazon is going to recommend you that, okay, you have watched this so and so on so and so date. Now, how come that particular device knows that, okay, you have been going through the particular products for purchase on so and so date? Now, that's where your machine learning comes. Okay, it is trying to just find your behavioral pattern. Like, okay, this person has been purchased, maybe they have some interest or desire to purchase, then they try to focus on it. Then traffic predictions. When you go for these Google Maps, okay, you have multiple lanes to go to the destination, but still there is some sort of busy road where traffic is more, where the other lane is very good, there is no traffic. Now, how that particular prediction is being given to you? Now, that's where the machine learning comes there. The speech recognition. So whatever you talk, that need to be recognized and that need to be converted into some text. Now, that is also the part of your machine learning. Then image recognition. Now, this is for you need to identify which one is car, which one is some animal, or which one is some human being and what. Okay, so that's where your image recognition concept comes. Then automatic language translation. Now, some people doesn't know English, some people doesn't know some other language. I want to translate that. Now you talk in English, but some other people understands in Arabic. Now that is going to automatically translate into Arabic. Now that is also where the machine learning comes into existence. Then medical diagnosis. Now here also, I need to just find out the symptoms of the particular person. Maybe I go for computer vision in order to find out the X-rays and all these things. Or some other case, in order to identify the symptoms, and we need to provide this proper treatment for that. So earlier days are gone where we do number of tests, but now all the machine learning is been doing that. But ultimately, the whole and sole response lies on the people, not on the machines. But here, obviously, whatever the data you give, based on that, your outcome will be there. So these are few applications based on your industry, how they are using. Now coming to the working procedure of how your machine learning is going to work. So I was saying something, you have a problem. So you need to define the problem. Based on the problem, you need to go for the data collection. Okay, I was saying something called you need to input the data, right? So you have some Excel sheet, you have some data into that, or you have some CSV file, you are having some data, you have an image, number of images into one file. Now everything is called as a data. So based on your application, you try to check which one is suitable for your problem. Okay, suppose your output is an image, then obviously you go for image data set, right? Some numerical, you go for numerical data set. So relevant data to be collected. Now, what are the data you're collecting in the real world may not be appropriate. Means some data might be missing. Okay, some sort of values might be different. So what you need to do is, once you study your particular data set, like maybe Excel file, some columns are missing, something is with different characters. So all these things you need to remove. And you need to make the particular Excel sheet with the proper data. Now that particular concept where you're removing the missing data is called as data pre-processing. So that you have your apt data now. Then which algorithm you need to go for? You need to go for the model selection. And based on that algorithm, you need to train. Let's suppose you have some 10,000 records as a data, and you need to train your algorithm, right? Based on your data. So 80% of your data, maybe 8,000 set of records, I'm trying to train to your algorithm. Now I need to test, right? I need to test it. So I go for model evaluation. You have remaining 20%, like 20,000. Okay, like 2,000, sorry, 2,000 records have been existing. 8,000 you have been trained, 2,000 is remaining. You just based on that, you test your model whether it is fine or not. Maybe sometimes you may not get your appropriate result. Then you go for hyper tuning. Some features which are not relevant, you remove that. And that is unnecessary features, that means unnecessary parameters you try to minimize. Okay, then finally, you need to go for model deployment and monitoring once you feel like, okay, your model is apt now. Okay, now this is the procedure of your machine learning working, right? Then types of machine learning, we have three: supervised learning, unsupervised learning, and reinforcement learning. Now, what do you mean by supervised learning is learns from labeled data to make predictions or classified data. Either I want to classify some data or either I want to predict the future scope of any problem. I go for these all types of learning, but here we need to highlight labeled data. Labeled means already I have some columns with some labels. Okay, labels means headings. Okay, maybe in some other slides I will just make it clear. Like suppose if I go for some student record, roll number is one label. Okay, that's called a feature actually. Feature, we call it in our machine learning terminal feature. Second feature could be student name. The other feature could be gender. Now these are all columns, right, where I have an appropriate label for that. Now that is called labeled data. Now under this, we have some examples like spam detection, what I was already mentioning. Then customer satisfaction predictions. Now customer satisfaction prediction means what? Generally, when you go for this Amazon, you try to give a review or rating or survey. Now, based on that means if your customer is satisfied, then obviously you give a proper rating, right? Now, based on your data, also whatever you are giving as a review, now that has also been teaching the machine learning. Like, okay, this product is good because this has been given so and so rating. Now, when you go for in a cab, ultimately, after you reach the destination, you need to rate the particular person. And that is also been helping out. If you give five rate rating, then obviously you might get more offers, right? Then fraud detection. This was also I was highlighting, right? Online cyber attacks. So how do you identify the frauds? Okay, on what basis? What is the criteria for analyzing the fraud? That you need to identify and feed to your machine learning system. So wherever the label is existing prior, your output label is also we can define. Okay, so that comes to supervised learning. Now, unsupervised learning finds patterns and relations in unlabeled data. So where you don't have any sort of predefined labels at all. Okay, now in this market segmentation, I want to divide the market into different partitions. Like, okay, this market zone is for so and so purpose, this market zone is so and so purpose. These are the customers for that. Okay, so like that, I need to partition classification, what I mean. Then customer clustering. Okay, this customer, these number of customers are willing to purchase so and so product called A. The other group of people are being used for product B. Like that, I'm trying to form a cluster. So that by seeing those people, I can say that, okay, these people are interested in so and so parameters. Then obviously I need to make that particular product ready. Then anomaly detection is nothing but the error detection. So whenever any faults, like I was giving some example, no? The intrusion detection systems, any sort of errors or any sort of anomalies occurs, no? That means how to identify that is most important. Then obviously solving it is a different case, right? So these sort of all comes under the unlabeled data. Now reinforcement learning learns by interacting with an environment and receiving rewards or punishment. Now we are very happy when we receive some reward, and we are very much interested to go further. We get a negative feedback, then obviously we stop and we try to fine tune that and we go further. Similarly, here also, whenever you play a game, then obviously you get a very good score. Okay, you are happy and you go further. Whenever you are just losing that, then obviously we try to drop out the interest, and we need to regenerate our interest in order to score much more in a different scenario. Same thing applies here also, where we have self-driving cars, where we have gaming playing API. Now, whenever you go in a proper route without any driver, you're going in a proper lane, then you get very much, that means you get a positive feedback. Then obviously you're happy and you learn from that. Okay, here the traffic signal is there, you need to stop. Suppose you hit a particular obstacle, then obviously you get a negative feedback. The next time you're not going to do that particular mistake. Now that is nothing but based on the rewards or the punishment you are trying to learn. So the machine learning algorithm which is coming for reinforcement learning, it is trying to learn itself based on the rewards. See this diagram, you can understand much more for supervised learning. So here you have some sort of items. And here I have given some labels for that. Can you see one thing for carrot, one for tomato, then bell pepper. Now these are the labels and these were the actual data. Now both are given to your model and I'm training that particular model. Okay, if you get this picture, this is the label. If you get this one, it is the label. Like that I have been training. Now once you trained, what you need to do, you need to test, no? So I have given this one without labels now. Carrot and bell pepper and tomato, each one I have given. That means each one I have given to as a testing. Now you have a model, which is your algorithm, which is already trained with some data. 80% of data we are given here. 20% I'm giving here. Now I want to go for prediction. Now first I take carrot. So it is giving the resemblance of, okay, this is giving the label called, okay, this item is called as carrot. Second one, you can see bell pepper. Third one is tomato. Now this is trying to predict correctly only, right? So this labeled data, if you are having like this predefined labels, then outcome is also being labeled wise, then this is called a supervised learning. Okay. Now, coming to the key applications of supervised learning, email filtering already I was pointing out, predicting of stock prices. So you might have seen every time in the news, what sort of stocks are existing, what are the prices, what are the shares existing, so whether it is increasing or decreasing or not. So if you want to invest some amount into the shares, okay, the stock exchange, then what you need to do, you need to have some idea whether that particular thing is good or not. So how do you know that one? So you can go for a machine learning algorithm which can assist you in order to predict, okay, on some sort of criteria. Okay, so we are not going to depth of criteria here, but here we are trying to focus on industrial aspect, where how this particular algorithms are being, that means how this machine learning is used in industry. So here you are trying to predict the stock prices. Similarly, I was pointing out medical diagnosis, right? So predicting diseases based on the symptoms. Okay, that means instead of doing number of tests, maybe we try to go for some minimal sort of test where that particular test has been using machine learning algorithms and it is going to predict. And based on that, we can diagnose that. Then image recognition, image identifying objects within images. So every image, when you take out, you have some lot of pixels, lot of shapes, lot of lines, lot of ridges and all these things. So I need to identify that. So then you give an image, then all these things can be worked out. Then coming to the unsupervised learning. Now here we have some data. Here we have some data where I have not put any label for that, which is called unlabeled data. Now here I'm trying to give that the complete thing without any labels. Okay, in the previous one, supervised, I given a tomato, brinjal and all the things. But now I'm not putting anything that I'm trying to give. Now here you have an algorithm which comes under unsupervised learning. Now based on the input, it is trying to process, and here it has been categorizing. That means it is classified. Maybe here you can do one more classification, right? So like this, you are given individually, but here it is trying to classify the items based on the parameters, maybe the color, maybe the height and all these things it is trying to segregate. Okay, so unlabeled data, if you're using, it comes under unsupervised learning, where you go for classification of items. Then here we have the applications like market basket analysis. Here, discovering products that are often purchased together. Now, when you go to a supermarket, then obviously the way of arranging the items in the supermarket has also been different. You can't find the items in a very zigzag manner. So they try to analyze the people mindset. Like, okay, the person is coming for a milk packet. Maybe he want to purchase some biscuits also along with that. So they will keep side by side. Now, if you are purchasing some biscuit, you want to purchase some chocolate also if required. Maybe they are keeping it. So that is the analyzation what they are trying to do. So if at all you want to make some prediction, like what sort of things the people are being very much purchasing. And if one they're purchasing, maybe they are desire to purchase some other thing also. So you try to keep side by side. So that sort of prediction you are trying to make here. Then we have a social network analysis, identify communities with large networks. Now, when you go for the social media, you have some communities, some groups. Okay, when you go for this Facebook, you have some groups or community. Now, if you want to just segregate, what sort of communities are existing? How many people are been existing? What sort of interests are there for the particular people? So if you want to do that, then you go for social network analysis through machine learning. Then anomaly detection, what I was pointing out is spotting fraudulent transactions in banking. Here, the example is for banking. Now, let us suppose you just log in and keep it your system like that only, and you try to just do some other work. Immediately, the session will be out. Why it has been out? Why can't it be logged in for hours and hours? Because there might be some fraudulent operations which can be done. Now, when you go for an ATM, after 3 times it is going to get a block. That means some fraudulent transactions are being working out. Maybe you are genuine, but system doesn't know. No? So system is trying to apply the algorithm there. So it is trying to find out that, okay, there is something wrong. You need to stop it. Okay. Then the genetic algorithm grouping genes with similar expression patterns, where it is going to show some fitness sort of functions. Okay. The expressions it is going to show, where it is trying to just analyze, okay, this genetic is with so and so fitness and so forth. Now coming to the reinforcement learning. Reinforcement learning is a learning method in which an agent learns what to do in a given situation by performing actions and receiving feedback. Now, I was explaining, right? You get a reward, you try to do much more positive aspect. If you get a punishment, you need to correct it. Yes or no? So that sort of learning. Here, key components, if you go for program, now the learner or a decision maker is called as an agent. Because I learn, I move forward, I find something wrong, then I go for next other step. Okay, like that I'm going to learn. Environment is nothing but the world in which the agent is going to move. Then state is nothing but what is the current state of the agent. Whether he is in sleeping mode, whether he is in active mode or what. It depends on situation, okay? Then action, choices available to the agent. So it means what action I need to perform. So this is the input. What is the next available outcome I need to do? Now, okay, I do some action. What is the reward for that? Reward is nothing but the feedback from the environment. It could be positive or negative. And based on that, the policy has been framed where strategy used by the agent to choose action. So in what way I need to plan in order to choose a certain action? Because I have done some action, it could be positive or negative. Positive, it's fine, no problem. That's also one sort of learning. If negative, I need to learn something new where I need to create negative. That means I need to create positivity from negative. Okay, so that policy you need to frame. Now coming to the how the reinforcement learning works is agent is observing the current state of itself, and based on the status, you go for an action. Based on the action, the environment is giving a reward. Agent, based on the reward, agent is going to update his policy strategy. Then the process is going to repeat until the optimum behavior is learned. Now, optimum means that is a suitable behavior. Because I said some negative aspect is there, some positive aspect is there, maybe the positive is also not suitable for sometimes, then what is optimal behavior which has been exactly suiting for the particular operation? If you go for self-driving cars, obviously you need to see that there is no obstacle, that means there is no damage for a particular system, or whenever they are moving in car, there should not be any problem for the passengers and sort of things. So what is the ultimate thing what you need to set up for your system is called as optimal behavior. Now this is the diagrammatical representation for your reinforcement learning, where I was saying that raw data is input. Now this is completely a different data what I'm giving. Okay, now it is going to the enter into the environment. Based on this current state of the agent, it has been accepting that particular raw input, and it is selecting the appropriate and based on that, some action has been performed. That action, based on the action, the environment is rewarding. So it's a cyclic process to learn. And based on that, you can see a different classification it has been made. So you can observe this data and this one, completely different. It is segregating. So based on that particular reward, the next status has been applied again. So it is a cyclic process. So if your reward is good, much more thing has been done. If your reward is not that much, it is trying to learn itself. And finally, it is generating the output in a proper way. Okay. Now, what are the applications you find for reinforcement learning? Is one is video games, where I was saying some scoring concept is there. So teaching AI to play and excel at complex video games. Okay, so based on your scoring, rewards are being achieved. Then based on the rewards, you need to improve that, or you need to, if you are not, that means not scoring, so what to do? Then autonomous vehicles are nothing but self-driving cars, which I was already highlighting. The robots, enabling robots to learn tasks like walking or grasping objects. So it is very similar to the autonomous vehicles. Now they also learn, and this one is also be learning. So what are the instructions you give? What are the instructions you feed? Obviously, it is going for that. And based on the sensor aspect, the data has been captured, and it is going to learn from itself. So here also the positive step, you get a reward, negative step, you don't get a reward. So personalized recommendations. Now, when you go search the web, no, let's say you take Amazon only. You try to browse some 20 to 25 products at a certain point of time. But it is going to personalize the recommendations for few. Because you might have spent a lot of time in order to search only for few products among 25. So those products comes under the personalized recommendations. Okay. Now, Now, the other most important aspect here is a data set. Now, the data, whatever you're feeding to your application, that means the system, is called as a data set. A data set is a structured collection of related data, usually organized in rows and columns. So you take any Excel sheet. Now, the Excel sheet, you have some values like rows and columns. You feed some data into that, and that can be called as a data set. So irrespective of number of records, that particular thing is called as a, if you take 5 records, you take 500 records or 5,000 records, maybe it is called as a data set only. Okay. Now it forms a for many operations, techniques, and models used across industries. Now, what all applications I was explaining, everywhere the data set is being given as an input. But it's not like 5 records, 100 records, 1,000 records. It is in lakhs and crores of records. So how many, that means how much more you are going to feed, that much best your decision will be. Now, what does the row set data set contains? Data set contains rows, that is horizontal rows, which we call as individual records or samples. Then the columns are called as attributes of the variables. Now the features is nothing but your actual input variables. Okay, input variable used for analysis or prediction. Maybe if you take one data set, you might have some 20 columns, but all columns may not be suitable for your problem. So what we try to do is we try to minimize that only to 8 or 9 features. Okay, that 8 or 9 are called as features completely. The 20 are called as columns for you. Okay, so you need to find out which will be input for your system. That particular columns are called as features, input variables. Now, what is the column which is being used for output? That is called as label. So we call it target output to be predicted is called as label. So 8 columns are input, 1 column is an output. Okay, that output is called as a label. That 8 columns are called as features. The 20 columns are called as the normal columns, right? Now, why we need to go for data set? One is to analyze the data, because you have a lot of data, some thousands, lakhs of data, then only your machine learning is going to work appropriately. So I need to analyze the particular data properly to make a decision, or you go for some prediction. Provide the raw material required for analysis and make proper decision making. Now, training machine learning models. I need to give some input. That means to give input to your model. Model is nothing but your algorithm which you want to run. So for that, I need to train. So that's what I was saying, no, 80% of your data set is being given as training. 20% I'm going for testing. How much you train, that much best your results will be. So enable the training and testing of machine learning and AI models. Their dataset is required mandatory. Discover patterns and correlations. So you are giving some features like 8 or 9 columns. So what is the relationship between the particular columns? Are you giving blindly that 8 or 9 columns among 20? Or there is some meaningful thing which you have been identified and made that 8 columns perfectly for your problem solving. So what is the correlation between that? You need to find out. Then innovation in case of research and development in industries like healthcare, finance, and education. Lot of research, we work with data sets only. Okay. Then evaluation and standards. So and professional projects, basically I need to have a system where I can evaluate the particular project properly. So still we experiment with some data sets there. Now types of data sets, if you see, we have numerical data set, you have categorical, right? Contains numeric data point that can be analyzed using mathematical and statistical methods. For example, temperature data set. I need to find out the temperature is cold, hot, or what. So on what basis? So I read some data. Then only I can predict, right? What might be the temperature tomorrow? On what basis you get a weather report? On all the aspects what I have earlier, right? Then categorical data set represent discrete categories or groups such as color, gender, occupation, or sports. Now here I have something like yes or no concept, true or false concept. Okay. Then time series data set records data over a period of time to track trends or changes, like stock price. I said the stock price are not constant. If you can see right from the morning to afternoon, every fraction of second, that means for few fraction of second is changing. That is called time series data set. Okay, it's not constant. Then ordered data sets where we give some ranking for your data. Which data is given the first rank, which data is given the second. Based on the priority of the data, I make my machine learning algorithm to learn. Okay, this data is given the first preference. This sort of data is given the second preference, like that. So here that will be examples are given like customer reviews, the survey ratings, or movie rankings. Okay, so this feedback system is working a lot in all aspects. Now, image data set where a lot of images I'm going to keep, I'm going to feed. Let's suppose I want to just find out, okay, this particular animal, whatever the picture I'm trying to give as an input is cat or dog. So you need to give a different variations of images to your model. All cat images, different looks, the dog, different looks. Then obviously we try to give an input of an image, then it is going to match and give the predicted output. Web data set collected from APIs or web resources, usually stored in structured formats like JSON format for further analysis. So if you want to go for web applications, maybe like Google is there, you just type some query, you're getting some lot of data. Now that particular data is also in a web data set. Now file-based data sets. Now this is mostly used in when you go for your Python programming, where we use files in order to extract the data set into my application and work out with some functions. Now, if your data is stored in files such as CSV, comma separated files, or Excel files, or text files, or Notepad for easy access and manipulation. Now, that's also been called as a data set only. Okay, so various types of data sets are there. So based on your requirement, you try to feed it. Now, this is an example for the tabular format you can see. Now, these are the columns. These are the rows. Horizontal is rows. You can see here. The columns is this one. Player is one column. Minutes is one column. Points is one column, like that. Now, this is a tabular format where it is going for rows and columns. Now, this is an image data set. So you can see lots of images have been there. Okay. This is a numerical data set. Or I can say here you are having some other data also, apart from numerical. So both in combination, numerical and alphabetical sort of character set, data set. Now, what are the features of data set? You can have numerical columns. You can have categorical columns. The size of the data, it depends now. What is the size of data you want to have? Because large data, you get very much prediction, right? Now, data entries, all columns or all rows, you need to have your data. Don't try to give an empty column or an empty cell. Now, finally, you need to do what? You need to have one column which is called a target variable. Now, this is ultimate output column. Okay. These are all the normal features. This is an output variable where you can find out your answer. Now, challenges when you go for the data set working, you have some challenges, quality issues. That means your data set is consisting of the complete data, or your data set is having some missing values. You have a lot of data set, that means a lot of repositories like Kaggle, okay, or you have GitHub, where you can see a lot of Excel files which have been uploaded by some researchers or some other industry people, where you can download and see maybe some cells are empty. In place of the numerical value, there is some junk value. Now, all these are quality issue problems only, right? So you have some missing data, there is empty. There is no data in the particular thing, but we require, right? Then bias, that is not a proper data. Okay. The mismatching of data. Then scalability. Very large data sets can be challenging to clean, store. Okay, you have some 10 lakhs of data. In that, 1 lakh is missing data or some other problem. So it's very hectic to clean the complete set of data, right? Then privacy concerns. Maybe you have some sensitive data or your personal data requires strict handling to ensure compliance with privacy and security standards. You can't blindly do the clearing of missing data or data pre-processing. Maybe some sensitive information has been lost. So what? So now that is a big challenge. So what you need to focus. Now, what are the applications of data set? We have seen already some applications, right? Where data sets are used in machine learning trainings. Okay, like image recognition, natural language processing, and fraud detection. Business analytics, where companies analyze sales, customer and financial data sets. Healthcare industries like patient records, medical images, genomic data sets. Education and research. Like I said, no, the researchers wants to extract the data. What I was saying, the GitHub or Kaggle. Okay, and you have some governmental repositories also where you can just download the relevant data sets and do. Then recommendation systems where we use data sets like Amazon, okay, for purchasing the products and so forth. So we have a lot of applications. Now, if you can see this pictorial representation, first column, second column, third column, or fourth column are called as independent variables, which are called as features, because these most important columns that have been. Now, this price is called as the label, which is nothing but your target variable where your predicted value. Okay, the final output is called as a label. The input, whatever you are giving, is the features. Okay, and obviously you know what is row and what is column, right? Now, what is a feature? A feature in machine learning refers to an individual measurable property or characteristic of a phenomenon being observed. Features are the input variables that the model uses to make predictions. Now, these features are also known as independent variables, predictors, or attributes. If I go back, size, beds, bars, and zip are called as independent variables or features. The target variable is nothing but your label, which is your output variable, where you need to find out the price value based on the prediction. Now, what are the characteristics of features? The features should be measurable. Features are quantifiable properties that can be measured and recorded. Now, that's what I was saying. You have 20 columns, but you're trying to take only 8 columns from that, which is a more proper input for your application, which is measurable. Independent. Each feature should be ideally be independent of the others. That's why it's called as independent variables. All features are independent. Varied types. Features can be numerical, like age and height, categorical, gender or color, or even text-based, like reviews or comments. Now, if you take one example, if we, in a data set for predicting house price, I want to predict some house price, I want to purchase. Now, features might be include the number of bedrooms, square footage, and location are your input variables. If I take spam mail, for a spam mail classifier, features could be the presence of certain keywords, the length of the email, the sender's address, or the keywords, maybe some promotional and the other things also you can put. So that particular features are measurable. Okay, so in order to predict your final outcome. Now, what is a label? Label is nothing but your dependent variable, which is nothing but your output that the model is trained to predict. In supervised learning, labels are known outcomes that the model learns to associate. Because you give a labeled input, the outcome is also label type. So if you remember, I was showing like tomatoes, brinjals, and all these things. You get the output as, okay, this is carrot, this is tomato. It has been giving label, no? So if you give supervised learning, labels are the input, labels is the output for that. Okay. Now, what are the characteristics of labels? Now, it should be a dependent variable. That means it dependent on what? Independent variables. If a independent variable values change, the dependent value is also been affecting, right? So labels, the final output variable is a dependent variable. Then that variable answer, that means answer variable could be categorical, like true or false, yes or no concept, or it could be your numerical values. So same example I take in a house prediction model, the label would be actual price of the house. Now this is an actual price is an output variable. In spam emails classifier, the label would be whether the mail is spam or not. Now that is the outcome variable for me. Now, what is training? Training already said you need to train 80% of data, right? So the process of feeding data to a machine learning algorithm, so it can learn for what? Learning patterns, learning the relationship among the variables, learning what sort of parameters are existing. Now that input data should be fed to your algorithm. That is called training. That's why I said 80% of training, that is a standard one. You can give 70 also, no problem. So that particular data you need to train to your model, so that, see, if you don't give training for the particular model, how can it give a prediction, right? That is simple logic. So what is the percentage of data you need to give? That you need to fix. So for what you're training, for learning patterns, for learning the relationship among that, for deriving the prediction. So what is the process? The model iteratively adjusts its internal settings to minimize the difference between its predictions and actual results, typically using optimization techniques. So the internally the model is going to see what sort of relationship it is holding, what sort of patterns we can develop, what sort of outcome we can generate with these input features. Now the data, the model is trained exclusively on training set, a portion of complete data set. See, a term called portion of complete data set. And 100%, 80% is one portion, 20% is another portion. So 80% is for training, 20% is for testing purpose from the same data set. Now the testing, why we need to go for testing? To evaluate the final fully trained model. performance and data it has never encountered during training or validation. Because I need to see, okay, I've trained the model, whether it is giving a proper output or not, whether it is predicting perfectly or not, whether I need to fine tune some parameters or not. I need to test it, right? Until I don't test, I cannot say that, okay, my model is very much good. Okay. So the model makes predictions on the separate independent test set, and its performance is measured using various metrics like what is the accuracy of the model, what is the precision or recall of the model. Okay, these are statistical terms. When you just go into programming, you can just understand. So what sort of correctness your model is, like 95% of accuracy it is giving or 99% of it is giving. So which model is better? Now, role in generalization means the results from the test set provide the most reliable estimate of how well the model will perform in real world scenarios and thus how well it generalizes. See, in the starting only I said there are certain problems which is real world problems. Day in and day out, suddenly it comes. Then obviously your work is to analyze it properly. If your machine learning is also saying that no, I can't go for real world situations, then obviously it comes on the traditional model only. Okay, so your model need to be in such a way that any real world problem instantly which has been coming, it need to be predicting that particular issue. In that way, you need to go for modeling that means the model need to be trained and tested, everything need to be fine. Now, what is a model actually? The output of the training process, a system that has learned to approximate a function or identify patterns from the data. So your input you are given that means the training data you have been fed to your algorithm. Now that algorithm studied completely about your data and it is ready to predict the testing data. So the algorithm with your training data is considered as a model. Now once trained, the model can be used to make what? Predictions or the decisions on new inputs. Every time something or other problem arises, the new data is new. See, if the data is similar, no issues. I can say that, okay, old problem also same. It's also same, so it is predicted. But it's not like that in the real world, right? New inputs are coming into. So how? It is trying to predict properly, or there is any problem you need to see. Now, what is the complexity and performance? A model's capacity, that is complexity, is a key factor in its ability to generalize. Now, overlay simple models turn to underfit, that is perform poorly on data set. While overlay complex models tend to overfit, memorize the training data. And so there is some concept called underfit and overfit. Now, overfit is nothing but which is more not irrelevant. Underfit is more relevant. So I need to see find the optimum solution among these two. Then only I can say that, okay, your model is going to be fit for the new data. Now, what is generalization? The ability of a model to perform accurately and reliably on new. Now, this term you need to remember, new, previously unseen data, which is not earlier seen, that is drawn from the same distribution of the data used for training. So I already have given a lot of data for training, but now what I'm trying to test is something new. Now that particular new data, what I'm giving need to be assessed properly by your trained model and it need to give a proper output. Now that is called a generalization. That means your model is being applicable for any sort of problem. Okay, so generalization is the primary objective of your machine learning. A model is only useful in real world applications if it can adapt to new situations and data beyond its initial training set. So there is something called gap, the difference between a model's performance on training data and its performance on test data. So let's suppose there is a gap of 30%. Then I can say that, no, it's not that much good. Okay. So if I say that, okay, 95% of accuracy, if your model is giving, no, then obviously I can say, okay, only 5% it's fine, no issues. Okay. So that gap need to be minimized. Now, till now, whatever we have seen is machine learning. I'll just quickly go through with the concept of deep learning. Now, deep learning is a subset of machine learning. So first it was AI. Under that, we have a subset of machine learning. Under that, we have a subset called deep learning. Okay, now this deep learning is using something called neural networks, artificial neural networks with multiple layers, which is called a deep neural networks to automatically learn patterns from large amount of data. Now, what machine learning can't do? That means your capacity of data is much more. Then obviously we adopt deep learning concept. Neural network is something which is related to your brain. When you talk about your brain, the human brain, we have something called neurons. And every neuron in your brain has been internally connected. Now, those are been called as layers, right? So we talk about artificial neural networks. Now, artificial neural networks are computer systems designed to mimic how the human brain processes information. Now, let's say you are writing some exam. Tomorrow is your exam and you prepare today. And tomorrow you need to just recollect. So whatever you're studying today, your brain need to function properly and your brain need to recollect that, which I'm calling something like experience. You have studied based on that experience, you're trying to recollect. That means every neuron is getting activated in your brain, and every neuron is communicating with the another neuron in order to send or transfer some information. And that information you are trying to produce on the paper. See, just like the brain uses neurons to process data and make decisions, artificial neural networks use artificial neurons to analyze data. That is one thing. I want to analyze some data. Then I want to find out the patterns from that, and I need to predict some output. Now, these network consists of layers of interconnected neurons that work together to solve complex problems. So I'll show in the pictorial representation what is a layer. Just remember, we have some internal layers. Each layer is going to process some input, and that output will be again input for the next layer. So a very crucial sort of analyzation has been going on in order to predict perfectly where a very huge data set has been given. Now, the key idea is that ANNs can learn from the data they process, just as our brain learns from experience. Now, that was a correlation what I was making. You are learning and you are getting experience, you are delivering on the paper the next day. Similarly, the artificial neural networks are also been learning. Every layer is learning some other thing and processing and giving that input as an output for next layer. They are used in various applications, from recognizing images to making personalized recommendations. So what all applications we have seen, that all things can also be performed with your deep learning, where your data set is very huge. Now, if you see the pictorial representation, we have an input layer. Now, these are all in nodes format, okay? Or I can say something called neurons, which are internally connected. Input layer. Now, these layers are hidden. Now, these layers are called as processing layers. Now, this input is given to this, and this is going to process, and it is generating some output and given to the next hidden layer. Now, this input, whatever this is giving, is being input for this node, and it is being processing and giving to this one. But here, that means we have different types of networks. So where all nodes are connected to all here. Okay, some types of neural networks are there. So these are the layers which are internally called as processing layers. So your input layer you are giving, your output layer has been what we call here prediction. Okay, and these are the processing layers. Now, working of ANN, we have input layer. What I was saying, data such as image could be data, text or number could be data. You are going to feed into the network through the input layer. Now, this is an input layer through which you are sending. Now, hidden layers, each neuron in the hidden layer performs some calculation on the input, passing the result to the next layer. The data is transformed and abstracted each layer. Now, this input is given to this is processing, and this output has been given as an input to this one. This is processing, and final output has been given. So till that particular final output, it is going to store here only. The output layer, after passing through all the layers, the network gives its final prediction, like it could be classifying an image such as cat or dog, what I was giving earlier example, right? Now, what is a deep neural network? A deep neural network is an artificial neural network with multiple hidden layers. It could be some 5 to 6 layers or more between the input and output layers. The term deep refers to the depth of the network, meaning it has more than one hidden layer. I specified here one because I want to just go for multiple, but here more than 5 or 6 layers have been considered. Now, each layer consists of neurons, also called what? Nodes, that apply mathematical transformations to process and learn from the data. The hidden layers, whatever I was calling the processing layers, there we use some mathematical functions where we apply some weights in order to optimize the value in order to go for better prediction. Now, this is the deep neural network where you can see more number of layers. Now, this X1 and X2 is an input. We are applying some weight for these particular inputs, and we are forming some scores And these codes are being given to the function called activation function. This activation function is going to get that input and it is giving to the hidden units for processing, and that is being given to some other, that is leading to some other codes. These codes are given to the next level activation function, and it is given to the another layer. Like this, you have multiple number of layers. Now each one is having some weightage. Each aspect or each input is having some weightage, okay, some priority, where if your prediction is not good, I can go for backtracking. I can change the weights of the particular inputs. And again, I go for recalculation, because ultimately my work is to predict it very much properly. Okay, so this comes under the deep neural network. Maybe more than this, you can see in some sort of applications also. Okay, so here layer 1, layer 2, layer 3, where this internal thing is most important, because output and input, okay, we are predicting getting fine. But what is the thing happening here? Okay, that is most important for us. Now we have one type of network, feed forward, a deep neural network. Now this is when you talk about feed forward, now we go in only one direction. We don't go for bi-directional. So you can see a lot of inputs are there. Hidden layer is there 1, hidden layer 2, hidden layer 3, and output layer 1. So only in forward direction we are moving. Okay, and each layer we have some weights for each and every aspect. Now we have back propagation also. I have not put into this. Back propagation means I can just move back also and change the weights, and I can go for optimization of your output properly. Okay, so when you go for only in one direction, then obviously it is called as feed forward deep neural network, because you can see 3 layers are existing here. Every layer is processing some other data, and final output we are generating as a predicted value. Now, one more example where we see convolution neural network. Now, here I given one image called a zebra, and here I need to get whether the particular value is zebra or dog or what. Okay. Now, here we have a convolution neural network where we have one activation function, ReLU is on one activation function. Then we have one more, that means this layer by layer we are going for. Okay, this is the first layer pulling, second layer, third layer, where you can see this box where you are trying to find out some object of the image. And like that, all image objects we are trying to take, and we are trying to go for further filtering of the image, because there might be missing data, or there might be some other things which are not required for identifying. That we need to segregate part by part. So many levels of filtering has been done with the kernels, and we find that filtering is called a feature maps. And here we are trying to find out the fully connected layer, where I'm trying to ultimately predict whether it is a zebra or what. Okay. So we have internal some mathematical calculations. I'm not going into depth of that. Okay. But this is how your deep neural network works. Okay, this is one type of network where going for computer vision, we apply this convolution neural network. And why deep learning? Automated feature engineering. Unlike traditional machine learning, deep learning automatically extracts features from raw data, reducing the need for human intervention. So I given an image. Just now previous diagram you can correlate. I given an image. It is only extracting the features, no? Now no one is doing nothing. Only your algorithm is trying to extract each and every object feature now and giving the final output. That's called automated feature engineering. High performance and large data. Deep learning models continue to improve in accuracy as they are exposed to more data, unlike say standard algorithm that plate. That means more data than machine learning can take. We can go for deep learning where high performance has been given. Now, why deep learning? To handle unstructured data. Let's see, structured data means what? It is a nice table format, which is having some headings, which is column headings, row headings, and all these things where I can analyze. Okay, this particular student table is there, roll number is there, name, everything I can analyze. But unstructured data where I don't have any labels. So that type of unstructured data we are going to handle by deep learning, such as images, video, these are unstructured. Those data we can handle. Versatility in application. Now, deep learning drives modern AI technologies, including facial recognition, self-driving cars, virtual assistants, and chatbots. So you have a different dimensions of applications in deep learning where your deep learning algorithms are being embedded into this whenever the data is very much massive. High accuracy, deep neural networks often 4+ layers. I was saying 5 to 6 layers. No, it is 4+ layers. Offer superior accuracy in complex non-linear tasks compared to shallower machine learning models. So more layers internal for processing, more accuracy we can get. Now we have key applications of deep learning. So already I have covered few. Maybe see, cyber security means when you go for identifying the intrusion detection, then filtering of the packets, or I need to find out fraud detection, and all this is under cyber security. Then autonomous vehicles, again self-driving cars. Then computer vision is nothing but with respect to images, maybe the X-rays, then MRI scans. This all comes under the computer vision. Then we need to see the data science, lots of what sort of data sets you are going to take, what sort of prediction you are going to make. Then healthcare and medical sector, like finding out the symptoms, which are very much critical, which cannot be done with the machine learning aspect. Then social media analytics, natural language processing, speech and audio conversion, everything. Okay, so here very large data sets are been there, very much a lot of accuracy is required. Then you go for such application, such deep learning aspects. Sometimes combination, deep learning and machine learning combination we can do. Now, what is the difference? Now we have seen a lot of things like what is machine learning, deep learning. I will just conclude with the differences between these. Now, when you go for machine learning, a subset of AI that enables systems to learn from data without explicit programming. Now, this was the first slide, right? I don't go for programming. It learns from data. When come for deep learning, a specialized subject of machine learning that uses multi-layered neural networks. So deep learning means neural networks aspect you need to embed. Okay. Then performs, when you go for machine learning, performs well with smaller structured data sets. So the data set is minimal, but when you go for it requires large volumes of unstructured data like image and audio, text, etc. So data set is more in DL rather than ML. Now coming to the ML again, uses simpler algorithms such as linear regression, decision trees, support vector machines. But when you go for DL, we go for convolutional neural networks, then recurrent neural networks and feed-forward neural networks, back-propagation neural networks. Then generally faster, when you go for ML, generally faster to train due to simpler algorithms and smaller data sets. So data set is smaller, then very much fastly we can go for training that particular model. But here, longer training times due to complex models and larger. We have tons of data set records, then it takes obviously a lot of time, right? So DL is taking a lot of time to train itself, but accuracy is more. Now, when you go for ML, can be trained on standard CPUs, central processing units. But when you go for DLs, we have graphic processing units and tensor processing units, which is very much faster in execution. When you go for ML, models are more transparent and easier to interpret. Models are more transparent and easier to interpret, but when you go for DL, it is considered black box due to complex internal work. See, black box means the internal workings is hidden because number of layers are there. Obviously, it is hidden, right? Then ML is suitable for tasks like spam detection, fraud detection, predictive maintenance. When you go for DL, it excels in tasks such as image and speech recognition, natural language processing. Like I just go for speech, like just speak something, it is going to convert into audio or it is going to convert into text. Okay. Then when you go for ML, it requires more human intervention for feature selection and tuning. Okay, I need to go for selection of appropriate input variables. But when you go for DL, minimize human intervention by automatically learning features and optimizing. So in ML, we are going to select input variables we need to identify, but in DL, system itself, model itself is identifying what is relevant features. Then coming to the conclusion, machine learning provides flexible and efficient solutions for many practical problems. Deep learning excels when large data sets and high computation power are available. So more computation power is required comparatively with machine learning. Now together, ML and DL continue to drive innovation, improve automation, and shape the future of technology in education, healthcare, law, industry, and scientific research. Now, there are a lot of industries which have been using this ML and DL right now. Okay. And that's all from my side. And it's open for question and answer session.
Participants, you can use your chat box
Okay, participants can ask the questions. Yes, there is a question. I think how to create AI LLM model from the scratch.
How to create an LLM model from scratch.
Right.
So large language models, now obviously now we have some AI tools which has been basically used for creating your LLM models based on your natural language processing and the speech recognition. Obviously, when you just give your intention, whatever is there, then obviously based on that, the LLM models have been created. There are a number of AI tools. Now, if you go for this ChatGPT, now that's an LLM model where you can create yourself by going for some parameter training in ChatGPT, where you can create your own. That means on your name also you can create a ChatGPT model where you can just fix the particular model for only a specific purpose. Okay.
I think second query is regarding the hands-on practice, and I think the organizers may give the proper answer to this.
Yes, yes.
Where we people are going to provide such kind of hands-on training there.
In future, we can think of hands-on training.
Right.
Workshops can be conducted. If participants are interested, then why not?
Yeah.
Let them be done.
Sure. Okay, so when should we prefer the deep learning over traditional machine learning models? This is the question from Pranali Mahurkar.
Now, whenever we have a very large data set, so I was giving an example for images. Now, when you go for this computer vision and all these things, right? So where we require a very large computational power is required, that is one. Then where we try to just analyze the image very much properly, which cannot be, that means which is not that much suitable for your machine learning applications. The machine learning applications can also do, but not that much accurate. You are going to get the result, how this deep learning is trying to do. Because if you can see the machine learning where we work with some central processing units, but that is not sufficient for this computer vision and all these things. So we require much more where we have tensor processing units, where we have graphic processing units. Now that has been suitable for your applications. So it depends. Now you need to analyze whether what sort of accuracy is required. Okay.
One more query from my side. Actually, as a database contains the mal data also.
Yeah.
So how the machine can sort out the correct or wrong data over there, because that there is a possibility because many people try to mollify the data, in fact, when the criminal type of cases comes there. So many times the data is mollified. So how the machine can identify that by using a deep learning rather?
Now, sir, when you go for this mollified data or identifying of the particular data, then basically the algorithm need to, that means whenever we are giving some training for that particular algorithm, we need to just identify some parameters. Like when you go for this network security, then obviously what sort of parameter is required in order to find out a threat.
Yeah.
Or when you go for these firewalls, whenever we are trying to take some input from through firewall, then obviously the firewall is going to restrict. So on what basis it is going to restrict? Because the firewall is having some rules, like rule 1, so and so purpose, rule 2, so and so purpose. So based on that rules, it has been identifying the particular threat. Okay, rule 1, it is going to stop the income packet from outside networks. Rule 2, then within the network also there could be some problem. then rule 3, so and so forth. So it's similarly, when you go for this malifying of your data also, we need to just think of what sort of parameters which is being suitable. Maybe sometimes the data flow is much more at a certain point of time rather than the regular time. Why the particular data is flowing or swooping the particular data in that particular time only? Why not the other time? Now, this sort of like this, we need to frame some parameters, and that particular thing we need to embed into our training model, so that whenever you input the malified data, then obviously with the particular parameters we can identify. Similar to the spam mails and what I was explaining earlier also.
Right.
How to identify the spam mail. So we put some keywords over there, and based on the particular keywords, these things are there. Okay, you try to put into the category of this spam folder, and
Right. Okay. So I think there is no any further question from the audience. So should I conclude this, or the organizers are going to do it?
Sir, your remarks?
Yeah.
Yeah,
So-
then vote of thanks. Yeah.
Yes. So altogether, we have very nice lecture from Dr. Mahesh Kumar. Right from he started with the machine learning, that is a very simple learning of the computer by using simple data, and after that going to the big data and deep learning over there, as well as he explained very well the difference between machine learning and the deep learning also. So I think this is a very beneficial lecture for the beginners as well as those who are very much expert of the all these things. The fluency of the lecture was very good, and you finished in time also. That is also one of the important aspect of this lecture. So I'm very much thankful to you from the whole audience, and maybe some another time we can have some other deep lectures from you. So
sure.
anyways, thank you for so nice lecture.
Thank you so much, sir.
Yes, over to you.
Yeah. Anandita? She. May I?
Yes, ma'am. Yes, ma'am. Just a minute. I'm just sharing my screen.
If she shares her screen,
Yes.
let me share my opinion. Sir, your delivery really matched my expectations, perfectly making the session simplified. The complex concepts were taught in such a manner that I think every participant would have grasped with ease. Kudos to you, sir, on that.
Thank you so much, ma'am.
Yeah, Anandita is there,
Yes.
so over to you.
Yes. Yes, ma'am. As we come to the end of today's enriching session, I now invite Dr. Harshla Pethe, esteemed organizing committee member, to kindly propose the vote of thanks.
Thank you, ma'am. May I audible, ma'am?
Yes.
Okay. Good evening, everyone. It is my proud privilege to propose the vote of thanks for today's enriching session. First and foremost, I extend our heartfelt gratitude to our esteemed resource person, Dr. Mahesh Kumar sir, for delivering such an insightful and informative session on machine learning and deep learning, the core concepts. Sir, your depth of knowledge and clear explanation have truly broadened our understanding and this rapidly evolving field. Thank you for sharing your valuable time and expertise with us. Thank you so much, sir. Now, I would like to express our sincere gratitude to our respected chairperson, Dr. Ganesh Kedar sir, for his constant encouragement and guidance, which always motivate us to organize such meaningful academic activities. Our heartfelt thanks to our patron and mentor, Dr. Abha Khandelwal ma'am, founder of AACST, for her visionary leadership and continuous support in fostering academic excellence and innovation. Special appreciation goes to our convener, Ms. Anindita Kundu ma'am, whose dedicated efforts, planning, and coordination ensured the smooth and successful conduct of this program. We also extend our sincere thanks to our panelists and organizing members, Ananta Ranchan, Dr. Geeta Lakshmi, Ms. Shailaja Murthy, Dr. Kishore Dole sir. A special word of thanks to Ms. Mitali Dani for her gracious introduction of the resource person. We are truly grateful today to the 100 plus participants whose enthusiastic involvement made this session interactive and impactful. Thank you so much, dear all participants. Lastly, I thank everyone who contributed directly or indirectly towards making this event a grand success. Thank you once again to you all. Now, over to you, ma'am, Anindita ma'am.
Thank you, ma'am. As we conclude day 2 of our national workshop, Artificial Intelligence, Concept-Centric and Industry-Oriented, we reflect on a highly enriching session on machine learning and deep learning. Today's session helped us to understand what machine learning is and why it is essential. Different learning paradigms like supervised, unsupervised, and reinforcement learning. How deep learning and neural networks enable machines to learn complex patterns also. In essence, if day 1 explained what artificial intelligence is, day 2 has clearly demonstrated how artificial intelligence learns. Tomorrow in session 3, core functional areas of AI, that is how AI works, we will move further to explore how AI applies this learning in real-world system, covering natural language processing, computer vision, and pattern recognition. I encourage all the participants to join tomorrow's session with the same enthusiasm, as it will connect learning mechanisms with real applications. With these words, we formally conclude our day 2 of the workshop. Thank you all.
One more thing, ma'am, it is really incredible that your team is working very good.
Thanks.
I mean, after very long time, I am seeing this kind of flawless presentation over here on the online basis. Because
Thank you,
generally
sir.
something happens here and there, but here it is really flawless and sticking with the time. That's very commendable.
Thank you, sir. Thank you.
Participants, kindly fill the feedback form.
So,
Remember, this is your attendance.
thank you, Mahesh sir. Thank you, Ganesh sir. I
Thank
think
you,
we
Ganesh
may
sir.
leave.
Thank you, Ganesh sir.
With your kind permission, convener or host Anandita. All of us can leave, right? You
Yes.
will
Yes.
collect feedback and will go ahead with all
Yes.
the
Thank you, sir.
formalities.
Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank
Thank
you,
you,
sir.
Ganesh sir.
Ananta, ma'am.
Thank you, Mahesh
Thank you
sir.
so much.
Thank you.
Thank you very
Thank
much.
you.
Thank you. Sir.
There's a small announcement, participants. Those who didn't fill the Google form, kindly fill it. Or if you have some difficulty on filling that form, let me know. You can call me. I have already mentioned my number in the group. Thank you, Kishore sir, for joining. Thank you so much, Mitali. Participants, please fill the form and then you can leave the session.